Hey, Deathbringer, you jumped right in. You must get a notification. I didn't think YouTube did those anymore for me. All right, I have tweeted.
Okay, let me grab those links.
Hey, a bunch of people have shown up. Hello, everybody. Nice to see you all.
Hey, pleased to be here.
Let's see if I can get the resolution any different. Actually, think that's kind of okay. Let's get this window. Yeah, it works. Good old Windows 7. Let me just turn power. I don't want the display to go off, otherwise you'll get that no signal error. Okay.
Yeah.
All right. So, um, welcome to everybody who's joining. We are going to be doing lots of nerding here. I wanted
Yeah.
I wanted to test a bunch of these devices that convert audio. And thanks to Artemio and his group of awesome people, we now have software that could actually give us real results on it, not just guesses. So we're going to test to see how it changes the signal, if one's better than the other, etc. Um, Anything to add to that?
Basically, we're gonna be zooming into differences. The software, what it does is compare differences, which is the same thing as comparing similitudes or how similar things are. But it a perfect score would be an empty result. That's what I mean. So when MD Fourier shows you an empty graph, it's that the sound files are frequency domain identical. And when there's a lot of difference, there's a lot of stuff going on in the graph. And we're going to use that tool, which uses an audio signal that was created by Pinobatch. And he made an awesome test signal for use with MD4. And using that test signal, we're going to run that test signal through the equipment that Bob will check. We're going to record how that comes out from that equipment and compare the original versus the played back signal and check how different or similar it is.
Awesome, perfect. And can anybody let us know how the audio is here? Kind of hilarious that this audio is probably not going to be that great when we're doing an audio testing stream, but maybe we can get it kind of closer.
Yeah, that's right. So, hey, everybody, the bringer, Philippe Malvare. Oh, the bringer, Mr. Broken. Dacetin. Hey, how are you, man? Dacetin's been working hard on the 32x port of the 230p test suite. He's made some strides lately.
Hi. What's up, Dustin? Good to see you, man. Yeah, my voice is usually low with the boom mic, but hopefully I was able to get that a little bit better for you.
It's also true that he's going to be moving around the room, so he's going to be coming close and further away from the from Mike. And I have the privilege of just being sat down, so
Let
that's
me.
going to be different for both of us.
I'm not going to spend too much time, but if I could share this folder, this would make it much easier for everything. So let me just try this real quick.
Good.
And then Am I not connected to the internet here? Okay, so we're gonna have to use the USB stick to transfer back and forth.
There you
Um,
go.
so the first thing that we're gonna need to do is to, as always, double check and test the audio card that we're using. So this is an M Audio 192K, and we know the audio card's good because a bunch of us that use MD Fourier constantly use it. But you always want to start with a retest, a loopback test, because what if drivers went bad? What if your cable went bad? You never just want to assume when you're doing this type of testing, especially
Yeah.
because these results are going to get printed on RetroRGB, and we're going to give some of these devices good or potentially bad ratings. And one of the devices, the Schiit Audio DAC, I screwed up the labeling the results the last time we tested this, and I actually returned it because I thought it wasn't good at all, and I was very wrong. So
Yeah,
we will get to that.
you can always you can't be too careful with this. And also, there's stuff that we found out, like temperature, and especially placing a new hardware into the PC might change the behavior of the audio card. We've been chasing ghosts sometimes with very small deviations. When we add, for instance, I added a GPU to my PC setup, and that threw out of whack completely the audio card. And it's
Jeez.
because there was interference, and you know what was the interference, Bob?
What?
Power supply.
Oh, wow. Okay.
I needed to upgrade the power supply because since the GPU was using much more power than was usually done before, the audio card was fluctuating in voltage, and it took me a couple of months to figure it out.
Yeah,
I
I
was
had an issue the
frustrated,
other
and I
day
tried
where
to,
I was
yeah,
using shielded studio monitors, the ones that I'm using here. I'm using them as my back channel speakers for the surround sound here. I'm actually going to be doing a whole video on that as soon as it's done. And everything was working until I switched amps, and then all of a sudden there's this hum. And I'm trying to hunt, I did that nerd thing that I always do where I assumed it was a huge issue. And I ran wires through the wall, so I'm like, oh, maybe it's that, maybe a wire got pinched. And turns out it was a ground loop, and all I had to do was use the type of, instead of three prong, use a two prong power adapter, and ground is gone. Ground hum.
yeah. It's usually very basic things, and that's why checking the basics is very important because you're chasing ghosts for hours if you don't.
All right, so the stuff that we're going to be testing, I guess 44 hertz is probably the sound that's going to be going through it because these are devices that you use with your TV, your DVD player, your CD player, and stuff like that. So I guess 44 hertz would probably be okay, but do we, for the loopback test at least, go to 192 and see what happens?
Yeah, yeah, you can try that. It's the obviously it's the most demanding, 192 kilohertz, and just as Bob said, consumer equipment usually goes from 48 to 44. It's been shifting to 48 lately, and but 192 is demanding. It will be the most pedantic test that we can do right now.
I'm just gonna bump up the sample size too because I don't. It's not like we're recording music. Delay
Yeah.
doesn't matter. We just want it to not use up too much CPU stuff. So, okay, so this is something that we've done quite a lot on stream, and let me see if I can if I can do it without messing anything up. So the M audio control panel's got to be at 192. We're gonna go into the playback and recording devices and just double check that. Use this device that's there. Okay, recording. Listen, levels, properties. So I think everything should be falling into place here. Nothing that, yeah, everything seems to look okay. So we're going to be recording with Goldwave and playing back with Windows Media Player Classic, which we've tested both of those before, so I think this should be good. So I just
Yeah,
got to make
they don't
sure.
they don't process the sound. That's what Bob means. Because there's some audio players that do apply equalization to the signal and
Hmm.
change either the bit rate or uh, the noise floor or equalize the sound in further ways that we don't want.
change it over here. Funny, that still says 44. So let me just go back into Goldwave, double check.
Yeah. Usually you have to close Goldwave, change everything, and open Goldwave. Otherwise, it'll grab the device and won't let you change it.
Interesting. It still says 44 hertz here.
Yeah, it does.
Let me try it this way. Go to internal, and then change it to external after Goldwave's opened. Yes. Okay. That's right.
That was it.
So then, new 192. Now I'll change it to that so that it could sync on itself. And crosshair. Ooh, cannot start recording. What if it's on internal? Let's just see what happens here for a moment. Nothing. That's what I expected. All right, let's let me just double check. I think I might have forgotten to set the playback device as default. Yeah, that's all that was.
Yeah, was.
That's an easy mistake.
Yeah, so much to change, right, between tests.
Yeah. All right. Close. I'm using one of those keyboards with a touchpad built in, so I'm not as speedy as I normally am, but it's probably a good thing because then I won't make people dizzy blowing through these different windows all the time. All right, let me hit record and try to hit. Okay. So we are going. Hey, is that Don?
Yeah. That's Luca.
Ah.
And the Geek Girl, how are you?
And Danielle,
Glad
what's
to
up?
see you around. Yeah.
I'm toasting you with water, unfortunately, this time. No beer yet. I do have a zero
here.
sugar ginger ale coming up after this, so living dangerous.
So I'm judging you with water as well.
I was out mowing the lawn this morning after I launched the podcast. I got kind of a big lawn and a small lawnmower, so it takes like 2 hours plus. So I'm making sure I hydrate.
Yeah, I can imagine, and it's I imagine it's that time of the day where the sun is hitting you directly.
Yeah. All right.
What
I
you're seeing
always
there
get
is
nervous when I see that spike hit the ceiling there.
yeah, very close to the zero dBs. What you're seeing there is the audio test created by Pinabatch, and at the far left you have the sync tones, also at the far right, and in between you have frequency sweeps and some fades and a lot more effects that show us crosstalk and many other things. It's designed to align to audio blocks in hardware players, and the alignment is 3.3 milliseconds, if I recall right. Hey, Guillermo, nice to see you around.
Okay,
So
I'm also
Bob is
doing
recording.
44 right afterwards, so that way I could send you both the files. Would you prefer that I send you the waves, or I should have been saving them in FLAC to make it easier? But would you prefer that I send you the
Faster.
waves or the results?
FLAC would be faster because they are 12 times smaller, right? But whichever works fine. I
Okay.
don't have an issue. Just let me set up something here.
Cool. I think I would prefer to send you the audio files, and that way you could send me back which file you want me to put here on the window. That way I don't fumble through and grab the wrong example or anything like that.
Okay. Just as you wish. No problem. Okay. There you go.
Okay.
That's better. And now I can add stuff.
So funny
Um,
enough, a while back, um, we did one of these streams, and I'm pretty sure we did it live on camera. But I did the same thing where I just naturally saved it as wave by accident, and I wasn't sure if I could convert it. And of course, our TVO was like, "Well, let's let's do a test on it." And we tested live right there, and converting from wave to FLAC right here in gold wave, exactly as I'm doing it, made zero difference. And that's with
yeah,
the detailed MD Fourier results too. So
yeah, it's a good way to convince yourself and to check on MP3s and all those formats and see how they affect the signal, where they cut, any encoder, that kind of stuff. It's fun, at least for me.
yeah, me too. Um, okay, so
Hey, Unreal 49, glad to see you here. Gosh, Artemio, which ports of Snatcher or Polysnots do you prefer? Since I speak English and not very good Japanese, I prefer the Sega CD port. If I spoke better Japanese or knew Japanese in a better way, I would go for the PC Engine version for Snatcher. And Polysnots, I really like both the Saturn and PlayStation ports. The Saturn is more complete. I worked in PlayStation, so I have a slight bias there, but I must admit Saturn is better. That's it. And Don Luke asks the 16-bit audiophile project. If you don't know them, go check them out, please. Have you tried using Reaper in Windows for loopback tests that were great on Mac OS?
uh,
No.
no. So I guess let me get these files over to Artemio, and then I'll explain why we're using this ancient operating system here. Just drop these in for you real quick. And am I gonna have to buy Discord Nitro right here live on stream in order to do it?
Use with transfer or something. Don't worry.
Uh, you know what? I'll just do it. I was using it before. Okay, I got Nitro now. There we go. Um, so the reason that we use Windows XP or XP, geez, we probably could use XP, but the reason that we're using Windows 7 for this is because Windows 10 and Windows 11, and I'm assuming Windows 8, but I hate that thing, so I wouldn't use it anyway. But um, we're using that because the way Windows 10 and 11 process audio always adds noise to a signal no matter what you do. There are versions of Linux that work absolutely fine. However, I am embarrassingly bad at Linux. Like, I have to have people sit there with me like a child holding his parent's hand when I do a lot of things in Linux, because I could get to a certain point, and then when something goes wrong, I'm just lost. So uh, Windows 7 still seems to be fine. And in fact, if there's time at the end of this, I would like to show at least one of these, because I found HDMI switches I don't hate, which is rare. But I'd like to show an issue I found because Windows 10 and 11 don't actually send the resolutions that you determine in the on-screen manager. If it detects on an EDID that it's 4K and you set it to 1080p, it still sends a 4K uh, video signal, but then it just kind of stretches it to make it bigger. Whereas Windows 7, if you say send it, like right now, I'm sending 1024 by or 1280 by 1024, and that's exactly what it sent the AverMedia card, even though it's detecting it as 4K. So that's another issue that Linux doesn't have, that, or at least the Fedora builds that I've been using. But I just got to get better at Linux, and without people here, if Dustin or Rollman were here to walk me through this, I'd probably be able to be using Linux right now. But that would be a different stream altogether. That would be Blob learns Linux and stops embarrassing himself.
So I'm running right now, MD Fourier on the test. I'll check if I can. Yeah, I can probably show the results after this.
Cool. And just to answer Don's question directly, I have used Reaper in Windows 7 and Windows 10. It does work, but it is not intuitive. Like what I just showed here. Make sure that Media Player Classic Home Cinema is the default player. Make sure that the default play and record things are set up, and that's it. You basically just hit record in Gold Wave and hit play with the or just double click on the file and it starts playing in the other media player. Whereas in Reaper, you really have to go in and you have to change settings that don't feel like you should be changing them. Like you have to enable something and it feels like something's going to go wrong, but it doesn't, and it works perfectly. You just have to understand exactly what it is that you're doing. And then, of course, when you're rendering, you have to make sure that you only render the single track that you've recorded to. And that's just extra things that can go wrong. So if you need to use Reaper, absolutely. But I like things that are stupid proof, because anybody that's worked with me on these before knows that I'm usually doing 10 things at once. So I like to just eliminate any chance of my own failure in doing these tests.
Yeah. So there you go. It's very good. We have minus 116 dBs of noise floor, which is really good. It's really silent, and it's a flat line. There you go. 192 is really good.
Awesome.
Okay, you can see the results here. I'm going back to them. There you go. So it's a flat line. Okay. At minus 116 dBs. Let me just zoom in into that probably. There you go. So you can see what I mean. Here it shows that it's just let me scroll back to those plots. There it is, significant volume, 116 dBs. And here it's zoomed in. You can see that it's a flat line. And there you go. It's all good with 192 kilohertz. Okay. Let's do the 46 one, right?
Yeah, 44, yeah.
Yeah, 44. Yeah, sorry, I don't know what I'm saying. So I select the 44 sample that we have, and I also select Bob's recording. And I'm making them not in 4K right now. I made the last ones in 4K, that's why it took so long to render them.
Monty said, hey, I missed why Bob looks semi-max headroom today. Is it the color correction? Because I think I accidentally left it on auto white balance. Is it my hair? Because I'm all, I'm showered, but I'm all disheveled. I don't know. I think I always just look weird, so that's fine.
Generating the results. Comparing frequencies.
Yadagaras wants to know if you have any plans for PlayStation MD Fourier.
Rollman is working on that. Oh, wow. And I wasn't supposed to say that live, but I did. And he's made great progress. We have XA audio working right now, not using the synth directly. But there are a lot of problems with the ZKs and running them everywhere because of legal issues. And we usually work in a context where you can use like reverse engineered clean room stuff and not hacked or stolen SDKs. So that's what he's been working around, and he's got very good results so far. But we have to confirm several things, and we don't have a chipped PSX to check. We've been only able to run it through PSIO and through some Davios CDRs on maybe aging equipment, and we are not sure if those reference files that we have are reference files. Hence, why it hasn't been released in any way. Okay. Okay. So the test finished. Sorry, I was distracted by replying the question. But let me grab these files and show them to you. And what we got. Okay, OBS folder. Select folder, and there we go. Here it is. And this is what we got at 44 kilohertz. That doesn't look good.
No, I should do that again. I should definitely do that again. All right. Yeah. Just for the record too, once we get into the actual DAC testing, I'll make sure to either have Artemio full screen or I'll put the graphs on. I honestly thought this was going to be a couple of minutes of just showing a single line with no problems at all. So I'll figure this out in a second. It could be that I didn't restart Goldwave when changing the audio sound. Also, Monty, Danielle just sent me a screenshot. I understand what you mean now. I no longer have that dual input data path capture card. So my choice was to use my crappy webcam or just use the Lumix GX5's live view app. So that's why you see the lines going across the back, because it's just a window capture of the live view. So I didn't realize that. I'm so used to seeing it because I see it every day when I record on it. So
Okay, so I checked, and noise floor, for some reason, in that file goes lower than usual, and we are not making a fair comparison. I'm rerunning it, so we get different results, and check if that makes it consistent. We were comparing up down to minus 179 decibels, and that simply is not uh, it's not apples to apples, right?
right,
And
am I using the wrong file?
no, you're not using the ground file,
Okay.
or it doesn't seem so. But no, I'm still getting bad results at 44 kilohertz. Really, really bad results. I'm checking the files. Let me check if the audio file is properly.
Okay, and for Windows settings, am I doing 16-bit 44 or 24-bit?
24 is better. That's
Okay.
not an issue going down to that.
Okay, so
Checking the files. Off camera, sorry. Okay. It's taking a long time to generate them. I'm guessing there's really is a bunch of difference. I can check them in world wave and compare them visually.
And Danielle
But
said she thinks I might have had she thinks when I created a new file, I created a 192K file by accident. That could definitely be it. Good looking out, Danielle. Appreciate it. Yeah, right here. That was the last one
192
used.
kilohertz. But the recording shouldn't be an issue. It's good to have a recording at higher sample rate. It shouldn't affect the test.
Okay. Well,
But good catch, Neil. But no, the recording is from the proper file. From what I see, it aligns perfectly and has, but it has a lot of aliasing and noise for some reason at 48, at 44 kilohertz. Why don't you do at 48 kilohertz, and we'll work on that mainly?
okay, I'll do both. I'm doing one more 44 right now. That's almost done, and then I'll jump in at 48.
Once I have it already set up, we can check it fast. Um,
Hey, Jose's here. What's up, man?
oh, hey Jose.
Master Safier just saw the weekly news update. Yeah, I think auctions during a YouTube stream would be a lot of fun. I just want to try to find a way to do it that's fun for everybody. That kind of is fair. And the other thing was close. The other service was close, but I don't know. I still have that Anthem amp right there if anybody's interested. That thing's awesome. Okay, double checking attributes. So for the file attributes for the FLAC, maximum compression 16-bit stereo or
Shouldn't be an issue at all, either
okay.
way.
So I'll just leave it right as is, or
Yeah,
20.
since it does lossless, it doesn't matter.
Okay.
If you can do 24-bit, that's better, but
Yep.
no problem. Since you're recording in 24-bit, that'll give us a better noise floor.
Okay, so then I'm just going to change this here to 48. I need one of those auctioneer folks. Genovi does that as one of his gigs. If you've ever seen the videos he's posted, he's just as ridiculous sounding as you'd expect. I mean that with love, of course. Okay, 48, 48.
Okay, it tells us it's 48. Okay, good. It's using just to check, Bob. It's using the external references, the audio control panel.
It was not.
Oh,
It's
that's
using
it.
internal.
That's the issue. That's probably what caused the problem. But it isn't
So you
syncing,
can't
right?
start the
Until you play.
recording if it's set to external.
Yeah, but you have to start playing back the file for it to sync. So you have to
Okay, so I have to
yeah.
start playing. Then no, still cannot start recording.
Interesting. And well,
I think we
that's
did this
gonna be
last time, and I mean I could try. Yeah, it won't let me do that. Yeah, I think we did this last time, and it turned out to not be too much of an issue. So let's test again with these two files because it seemed fine with the 192 recording, right?
yeah, it did. It did.
Yeah. Okay. I'll have these two files over in about a minute.
Okay, I'll test fast.
Oh, Don said when saving in FLAC, 16-bit or 24-bit doesn't matter because it gets padded with zeros. Interesting. And yes,
Eh,
doing a loop back of the SPDIF out to SPDIF in on the AP192.
Yeah, that's what he's doing, and it would kind of matter in this scenario because it is indeed recording at 24-bit. He's not up converting from 16-bit to 24-bit. He's using 24-bit recording as a source. So let me check. Let's frame that a little bit better. It's 4.3.
Hey, Smoke Monster just popped by. How's it going?
Hey,
Good to see you, Smoke.
yeah, it's awesome to see you, man.
Okay, test 2 coming at you right now, and the 48K test as well.
Awesome. Got him. Downloading the 48 kilohertz test. Downloading the 44 kilohertz test. Okay. Go. 44. Downloading 48. Got them both. There you go. Let's test 44 first. Okay. I'm opening 44 first here. There you go. And running it as is without modification. It's 44 from source, 75 kilohertz. This looks way better. Okay. It determined minus 200 decibel noise floor, which is very, very low, way too low. And it's perfect. There you go. This 44, let me show it on screen. And but we have a perfect 44 kilohertz test. I don't know what happened last time, but it was bad. And this one goes to just imagine this buff. You're going to minus 200 decibels below zero, and it's very clean.
That's
Let me
great.
show it. There you go. There it is. And
Wow.
this is the result. Okay. There we go at 44. That's good. Okay. Let me
This is why we like
put
this
this.
old ass PCI card so much, is because of how small the noise floor is on it when doing these things.
Yeah, it's really good in general. And there you go. It's doing great. Okay. So 44 is good. Let me go for 48. How I'm telling this is good. Let me check what you're seeing on screen. The audience. Okay. Oh, thanks. Let me. You're seeing.
Should we
There we go.
also do an analog loopback test just to make sure as well?
We're going to use analog. That'll be good just to check. But I think we're good.
Yeah, I think because we've tested this card so much, I think we could, if we get weird results. Well, you know
We can
what?
go back and
Let me
check.
just do it.
Okay, that's good. That's great. It's good to be safe.
Hey, EL Colonel, thank you very much for the super chat. I really appreciate it. That is great. It's keeping this stuff going.
Hello, Colonel. Yeah, he always comes in joking about Lisa versus Min Mei in macros and Misa Hayes, Misa Hayase versus Min Mei. Hey, Gordial, how are you doing? And Don Lucas says, shouldn't SPDF loopback be a 100% match? It should be if the clocks matched perfectly from output to input, but you have a different sampling clock in the input and the output. That's why using external is recommended for external sources. But since you're using the same card as its own clock, it didn't work. That's why he couldn't select external in the panel. But you usually, when you measure, go to external to compare them. And yeah, SPDF should be perfect, but we haven't found many circumstances in which that really happens. But we're getting minus 200 dBs of close to perfectness, and I believe that's good enough,
So
especially for an audio
theoretically,
card
then
that's
we
20
might
years
actually
old.
get lower noise floor when testing like HDMI because we're not using the same clock. I think.
Anthony Dan asks us, hi, are these DACs, these DACs, related to any hardware in particular, like which consoles, computers, or arcade PCBs? Right now, we're testing the testing equipment, okay, just to make sure. But Bob is going to use a variety of things.
Yeah, this is so the goal of this is both to teach people how to do this testing for themselves so they don't have to rely on us, but also to test equipment like HDMI switches and just basic audio, digital to analog audio extractors, and to show people why you might want to spend 100 and almost $200 on the Schiit Modi. Yes, that is actually the name. Shit, I'm not making that up. But what the difference is, and on the flip side, why you don't need to spend a lot on HDMI to SPDIF converters if you're using 2.0 channel audio. So I just need to find my HD RetroVision cables, which I used
Let's
to
take it
have them
easy.
right here, but I don't know what the heck happened. I cleaned, and that's my curse.
Yeah, cleaning is always a mistake.
um,
I know that sounds wrong, but you're used to working certain way, and when you clean, you think, oh, this would be a good place for this thing, and it never is, because
Never
that's not
is.
where you usually place it.
Yep, I think I know where it is, and I think it's buried right here next to my Mister stuff. Yeah. I definitely need more boxes and another one of those racks.
Yeah, just and uh, and yeah, so the idea will be that in the real world we rarely get perfect results. As a matter of fact, I only recall a few instances where we do get perfect results on field. It's usually very good results, and even in pure digital, because keeping the signal purely digital without modification is harder than it seems. They told us that it would be perfect, but it usually isn't. We usually have small deviations or differences that MD4 shows us because it compares segment per segment between the frequencies. What MD Fourier does is imagine you have I like to I wrote a small analogy about how things usually work. Let me see if I have it handy. Yeah, I do have it handy. And it says, imagine you have two Lego castles that you want to compare, okay, built with Lego blocks. You could analyze the general structure by eye, but you couldn't be certain if their similarity is only superficial. For instance, one could just be a shell, and the other could include detailed inner chambers and dungeons. These structures cannot be judged just from their appearance. MD Fourier approach takes a different route. Imagine that you have a method to decompose the whole castle into its building blocks. This process could tell you with precision how many blocks of each color a castle has. You could also analyze smaller chunks of it, and the process will tell you which color the building blocks are and how many of each color were used. Of course, if this is true, that you can use such analysis tool to compare the pieces between both castles, but such comparison could tell you nothing about the structure. It will only tell you about the building blocks and but it won't tell you how the building blocks were placed together in space. But what if both castles were intentionally built to be the same exact castle? If the intention was to build the exact same castle. With this particular limitation, you could make some educated guesses with the tool results. If you deconstruct both castles and do a room by room comparison, you can start working with something to compare them. If the tool tells you that for a certain room you get 10 red blocks and 20 blue blocks for a castle, and 10 red blocks and 9 blue blocks for the castle 2, you can certainly say that the castles are not the same, even if you don't know how the blocks were put together in space. This is by making chunks or slices of the castle, 3D chunks, and comparing the building blocks in those areas. If you make those comparison chunks small enough, it says, now imagine that you design a specific castle and task two different people with building one from your instructions with any piece they wish to do. You could then analyze each part of the castle with your tool and compare the building blocks. If you define each area to be too small, a single block, for example, the comparison would be precise in telling you if the same building block where it was used, but would tell you nothing about the structure. But in the opposite extreme case, if you analyze a castle as a single unit, the tool would be useless again. What you need to do is your tool doesn't need to compare it that way. Your tool doesn't seem to be very useful at comparing castles. But if you segment the castle by area and compare each area in a predefined succession, then the result starts making a bit more sense. It would be a very improbable coincidence if both persons were trying to build the exact same castle, and each area that you analyze with the tool gives you the exact same amount of building blocks for each color, and you end up with an analysis that tells you they are identical. This type of analysis gives you a sequential dimensionals in space that the tool was incapable of producing. So in this analogy, the castles are the audio files, and your tool is the Fourier transform. The colors of the bricks are frequencies, and the amount of blocks of each color is the amplitude of each frequency. And that's exactly what MD Fourier does between the two audio signals.
That was one badass explanation. That was very cool.
I'm going to link it here in the chat for anyone if my English didn't get in the way.
No, your English is perfect. It's funny. Somebody in the chat earlier said that this was the first time hearing you speak English, which is just it's funny because I talk to you all the time and I really only hear you speak English.
Yeah, of course. We've only spoken English. It's always been a great time talking with you, Bob. Always a lot of fun.
Hell yeah! It's funny. There's going to be a whole lot of Spanish people coming to Retro World. So if you or any of your friends get tired of English, you got nothing to worry about.
I bet we won't get tired of English. Don't look at the 16-bit audiophile project. If you haven't checked their project and what they do, they preserve and make a catalog of reference recordings of 16-bit audio files from game consoles, of course. So go check them out. And Luca asks, are you using unbalanced cables to make analog loopback tests?
I'm using HD RetroVision cables
Mm-hmm.
into just basic RCA to quarter-inch jack cables. So I did at one
Yes.
point buy, I believe Don was the one that suggested the Hosa brand, HOSA,
Mhm.
these. But I end up, that's actually when I'm connecting my Motu M4 to my studio monitors, is with these. But there were a few tests that we ran that the HD RetroVision in these performed the same in these tests. So I could be wrong. Please correct me if I'm wrong, though.
Yeah, and the difference between balanced and unbalanced cables in general is that in balanced cables, you get cancellation due to interference. I mean, when you get electromagnetic radiation that we are completely surrounded by, cables catch these as antennas, okay? And a balanced cable has two runs of the same signal that are opposed in phase between them. And if there's interference that causes the signal to be distorted in one of the cables, and this is important to mention because if it happens in both cables, it won't happen at the same time. And this is the catch because there's a delay in time between signals. So when you construct the signal, you change the phase, invert the phase in one of them, and subtract them. And that completely eliminates any noise that you get because it'll be canceled by itself in balanced cables. And on in the unbalanced scenario, you don't have this. But it's at least for our measurements, even though balanced is highly recommended, unbalanced is good enough for these tests that we're doing. Okay, there you go. Bob's got a lot of files there.
I got both of the analogs coming your way now just to double check, and then I have the next device, and we're just gonna have to figure out the best way to go about testing that.
Yeah, let me sort them here because otherwise it gets messy fast.
Yeah, that's how I ended up messing up the Modi test last time. It was a mislabeling thing.
To take your time on this because otherwise it's very easy to make mistakes when you're bulk making stuff. It's better. Sometimes I find it easier to repeat to myself the steps I'm making and the audience listening to that.
Yeah.
Yeah, yeah, using unbalance you get less volume, of course, and also that reduces the noise floor. And you're right, don't look. We're not being as pedantic as possible, but we think that it's good enough for the circumstances. We could get like three or six of these from out of that as Don Luca. And let me create a folder that's called analog, and we'll use that. Good. So here you go. We got the 44 kilohertz analog loopback here, and the 192 analog loopback. Copying the files to the folder. Sorry, yeah, you're not seeing this, but I have a messy desktop and tons of windows doing other stuff, so I'm just clipping the windows that we are using for the stream. Find it easier that way, because otherwise it becomes messy fast. And copying the 192 kilohertz file, and we are still testing the tools, okay? The next step after this would be testing our first
Yeah.
DAC DAC. So I'm opening MD Fourier now. I'm checking the 44 kilohertz version of the analog one. And there you go. I'm running the test right now. And I'll show you the results in a minute when I get them. Okay. Removing this. And they are almost done.
And with respect, we are almost an hour into the stream, and we're just about finished making sure our test equipment tests right. So this is why this stuff takes so long, and this is why there's so much effort put into making sure that these tests are correct. So I'm glad that people are hanging out and seeing this, both because maybe you could use it to learn how to do it yourself, but also because it's kind of cool to see how this works.
4 kilohertz is really good. Okay, you can see there that I'm gonna zoom into the graph that you're seeing on screen, so you can see a zoomed in version, and you can see that it goes down in analog to minus 102 decibels for noise, and that's really good. Okay, that's really good. I'm resizing those to match the screen, so you can see them again after I scale them, and I'm going to jump between the files, and here's the noise flow, which is really good. So 192, 44, good, and it'll probably give us a very good 192 version. I'm running the 192 analog loopback test now. There you go, selected, running, and results will be in the display shortly. Okay. But so far, so good. We got good results. In between the 4 tests that we made, we got 3 so far that are really good. They're baseline and what we can expect to compare. Okay, a directory, and here it is, the 192 kilohertz version. There you go, and it's really good. You can see it's flat. We get a flat result, and let me see it locally, so I can tell you what it says. It's 103 decibels, the noise floor, and it's really good. We got a flat line, so we're really good to go.
Okay, that is absolutely awesome to hear. However, I think I'm missing a device that should have been here. We could still absolutely continue. There's a bunch of other stuff we could test, but it's funny. It's the device that Bernie asked me to buy a while back that converts between SPDIF and coax. I could swear it was right here.
They're handy. Meanwhile, I'll check on the chat. And Kevin Sauria, hi, asks us, what are you planning for dinner? And in my case, it's going to be cecina. That's salted and dried meat by air, sun, or smoke. And it's typical from certain regions of the country. So I'm having that with in place of a corn tortilla, place the cecina on top, just a bunch of cream, and maybe some sauce or pico de gallo. That's what I'm planning for dinner.
That is so much cooler than what I'm having for dinner. I'm having the other half of a bagel that was left over from breakfast. Well, I mean, so what I'm missing would only really stop one test from being done. I'm flabbergasted that it's not here because it's been here for months.
I know you couldn't. That happens.
I'm gonna blame Bernie. It's his idea for me to get it.
And yeah, just like Don Lucas says, that's a fantastic result for an analog loopback test, and yes, it is.
Unless it fell in a bag. Could that have been it? That would make sense.
I have one here. It's several thousand kilometers away from you.
I have a HP VR helmet here that a friend of mine let me borrow years ago, 2 years ago now, and I used it once or twice, and I thought it was neat, and then I keep needing to return it to him, and just keep forgetting. And I don't think he even misses it. I don't think he even uses VR at all.
Yeah, most probably. Since he hasn't asked for it, it's most probably completely unused.
Well, I've hung out with him a couple times too, and I keep mentioning every time I go there. I'm like, "Oh no, I forgot your VR thing," and he's like, "Yeah, I don't use it. It's fine. You can hold on to it. Try to use it for something fun." All right. Well, I guess we're gonna have to skip that test. That's odd. It was right here. It's been right here. But
No
okay.
problem. Gianluca tells us that the tedious part of testing your audio interface is just the setup, really. Then it's a breeze. It's really fast doing the actual test. Yeah, and the actual testing is fast, but just as Gianluca says, I hate just like setting up the cables and the stuff and the space. It's so much time. And cleanup after that. It takes a lot of time. Karen mentions, still, it's cool to see the process to learn what measurements you should take to be sure from a good reading with the DACs. Yeah. Nunes Kant, hey, how are you, man? Glad to see you around here. Hector Delgado says, uh, don't talking, which means that I shouldn't let them, how do you say that in English? Like when I talk about food and you want to have it, that kind of thing. I
Oh
don't know
man,
how.
yeah, yeah. All right, I found it. It was in the wrong box. So there you go.
Oh,
Always
good.
put your shit back in the right box.
Yeah, when you clean up, don't figure out new places for the stuff.
Okay, so what I wanted to do now is take this device by JTech Digital, and this is a device with 4 digital inputs: 2 SPDIF, 2 coax. So I'm going to use the coax input, and then it outputs both analog and SPDIF. Except R192 doesn't do the digital optical SPDIF. I know these terms SPDIF could technically go with both, but I always, to make it easier, call the one with the beam of light SPDIF, and digital coax is what I call the other one. If somebody has a better name, let me know. So
Use testing.
in order to test this, the SPDIF output, we have to use this other device by a company called Prozor that converts between the 2 digital formats. So my hope is that because we're going to digital, it's going to be a clean noise floor, and if it is, that means we get 2 devices at the same time tested. If it's not a clean noise floor, one of these two has a problem on the digital side, and we'll have to continue. So let me get all these things plugged into each other, and
Yeah, just like Lucas says, I think the same thing. Optical is generally referred to as toslink, and SPDIF is generally coax, or a general term for both. It's again being pedantic and specific. The important thing is that we know what we're talking about when we mention it. And as Bob said, I will call this for this session and this for this session. That's what's important. Having a standard.
as long as we label it properly, that's pretty much it.
Yeah. Just like Lucas said, it's wrong really because both are SPDIF. Yeah, both are SPDIF. It's a mess.
I just want to make sure I have another really nice, good shielded cable for this. I think this one's going to do just fine.
Talk about Toslink and SPDIF. Have you seen the Technology Connections video about Toslink?
Was that from a few years ago?
Yeah, it was.
I believe I have. I like him.
Yeah, it's really good.
It's, whenever people send me videos of random YouTubers, like, I always hold my breath because I think we've all seen some of the ones that just accidentally spread misinformation. And so when I first stumbled across him, I was just like, oh, I hope he's good. And it was the Sony Trinitron video. And I got halfway through it, and I was just like, this guy's awesome. I'm in. I'm subscribed. He knows what he's talking about. Or when he doesn't know what he's talking about, he just says it, which is totally fine. You don't have to know everything. Just don't pretend like you know everything.
Yeah, and he nerds out, and that's good because he doesn't limit himself to what's going to be mainstream. He just likes something, digs deep, and goes with it. That's good.
Okay, so I'm hooking all of these up. So I'm assuming that we should use 44 kilohertz for these testing these devices because a lot of these I'm assuming wouldn't support higher frequencies. But if you're talking about getting it from your TV or your video games, I don't think you're going to see 192 out of a video game console, right?
I believe most game consoles today are 48.
Really?
Yeah, but they should have 44 as an option as well. So that's good. As long as they support it, that's good.
I think the other reason I'm hung up on 44 is because a lot of the things I've been testing now, I found that music and like even files from your phone, your computer, they get transferred to your audio receiver at 44, even
Yeah.
though it's very outdated and it should be not hard at all for people to change it. So
It's a consumer standard, and the studio standard was 48. So that's why we have those that are so close. And 44 saves a bunch of space on CD-ROM. And right now, you should be using the external as turned on because you're using an external clock. Check if that works.
I'm still using the loopback from here though.
Sorry, I'm sorry. I'm sorry. If you're using the loopback, go with internal.
Yeah. So
Sorry.
theoretically, this should be exactly like the loopback test. If it's not, I have a feeling one of the cables might not be fully shielded. But oh, am I not getting signal? I
No.
probably needed to close this and reopen it for because I changed the default setting. So let me.
Hey, greetings, Carlos Nápoles, and hey, the Masked Man. ¿Qué tal, Carlos Nápoles? Easier in Spanish. It's so difficult to just switch. I'm not used to it, switching accents. Not good at that.
Oh, the input. That's what I didn't switch. Okay.
Okay, there you go. You have it.
I like easy mistakes because that means it's an easy fix.
Yeah, that's right.
Let me keep.
And they're the most common. There's just a bunch of them.
Okay. So input. I'm just gonna keep switching inputs until I get some signal.
Yeah, you're not getting a signal. Yeah.
I think I'm on the correct input. It's outputting here. Input side. Test link. I'm not getting a light out of the optical cable. So, okay. That means my optical cable could be broken, but luckily I have piles of them. So,
Good.
just go to the next. That's the very easy one when you're using the optical cable. If you get light coming out of it, you know things are working properly.
Yeah. And it's not a laser or anything. It's just a LED. So don't worry about it destroying your retinas or anything.
Okay.
Meanwhile, if the audience has any questions, we can work on that. Don't worry. This will be sorted out anyway when he got an input now.
All fixed.
There you go.
Yeah, all right. Record. Play. Okay. It's going to be interesting to label this file. JTech plus other plus 44.
It's I'm so bad at naming files.
Yeah. The one thing I always try to do when I'm doing tests like this is the final files are year, month, day, hour, minute, and then the name of the file. Because there was a couple of times with recording stuff when I was in the band that we would have different, oh, try version 3, try version 4, and never failed. We'd forget what version was which. So when I made everybody, they were so annoyed at first, and then I made them do it like that, and then there was never any worry. We got all the correct takes, all down.
That's certainly a good idea.
Okay.
Unix timestamp the file. Yeah, the file name.
This is gonna be JTech and Browser 44K digital. Okay. me grab my USB stick, and I will send this over to you, and then I will start setting up for the analog version of the test.
Sure. Okay, I'm creating a new folder that's actual tests. And this is 44, so I'm gonna get ready for 44. Ready.
Got it. All right.
I'm ready. Could you imagine working like this 20 years ago?
I mean, we would, day one would be testing the analog, day two would be testing digital, and day three would be testing each individual component. Yeah, it would be way different.
Completely different. So I got the first file from Bob. I'm running it right now with 44 kilohertz reference file. Running it now. And we got minus 200 dBs of significant amplitude for analysis. That's the noise floor. So it's
So it's the same as direct, minus 200 dB, right?
And we got a flat line, which is really good. Let me show it to the audience. And just takes a bit of time to set up in OBS. Not much. And there you go. Here's the result. It's a flat line at minus 200 dBs, so we're good.
Okay.
Of course, a more close inspection would be what we would normally do, but this is really good. I'm saying just flat noise floor at up to 200 dBs.
Awesome.
And it's really good. It's really, really good.
That proves what I had suspected, that almost every converter we've tested, in fact, I believe every digital converter we've tested has been almost perfect because it's digital. It's, it's not really, there's no need to change the signal. And in fact, you'd probably it would have to be a really bad design to change a digital signal noticeably enough.
It would be more expensive because you'd need a buffer and you'd need to process the data to change it, to bring it, right?
Right. So that means that, and I will be, as soon as this stream is over, or maybe in the morning if I'm really tired or something, I'll have links to all of this. But this proves that the Prozor converter that converts between, they have it listed as Toslink and coaxial here, but the two digital styles does its job perfectly. It just switches between the two with no worries. It also proves that the JTech Digital is able to take... it's basically a switch between different digital formats, and that seemed to work. So for now, what I'd like to do is test the JTEC's analog output, just to see. And I used this one for a while. I actually used it hooked up to my TV, and I have some suspicions, but I am not going to say anything just until. So, no, playback we're going to be doing still digital, because it's going to be digital out to the digital in of the JTEC DAC, and then it's going to be out with the RCA connectors analog.
So, a second, Gianluca mentioned a test that I have also thought about, but wasn't sure if I was going to run. And it turns out it's really interesting. It's we are comparing now it's not what you're seeing on screen. Let me just remove it. He suggested I compare the previous digital recording to this digital recording.
It's a good idea.
Okay, so I'm comparing your loopback test to the to this test going through the devices, and it's a perfect 100% perfect match.
Thank you, Don. Thank you. I appreciate that. Good suggestion.
So the loopback, and there you go. MD4 has these bars that are in the middle of the screen that tell you when a digital recording is perfect. It only uses that, as a matter of fact. and it shows 100% in everything. It's a perfect match.
Now, my just guess here is that this is not going to be a perfect match.
And Lucas says that's very, very good. It's important because you have proof that the devices are 100% transparent, and any distortion, noise, whatever difference what we're getting is basically the input and output capture, right? But the devices are perfectly transparent. I honestly didn't expect it to be perfect, Don Luca. I expected a small variation, but it's really good to see they're perfect.
Okay, so if anybody with an eagle eye notices, the sound files are significantly quieter, and that's because of how the M audio card does records. Artemio, you know a little bit more about that. Would you mind explaining it? Because I think it's pro level versus consumer level or something.
Yeah, it's what John Luca was mentioning before. And pro level is when you use balance cables and everything, it uses a higher standard, so you gain a bit more in noise floor because the signal is higher level. And when you use consumer level, the M audio card switches to a different way of digitizing or sampling the signal and has more headroom. But having more headroom reduces the dynamic range. So you have a higher noise floor. This was the Prosor and JTEC. And both, we can rely on those for 44 kilohertz right now, from now on, and say those are transparent. You can trust them.
Here comes the analog file.
Okay. Got it? And yeah, we don't expect the analog file to be perfect. But hopefully it'll surprise us. And running MD for you now. The analog test. This is the... Okay, something went wrong. Something went so wrong that it couldn't recognize the sync.
Okay, I will retest.
No, don't worry. I can. I implemented something for these scenarios, and it's manually aligning the signals. I can tell MD Fourier to manually align them if this is bad, and it is bad.
I'll do another one just for the heck of it.
Yeah, I think that it was indeed a bad recording, probably, because no, it's something. It has something to do with the way that it decodes the signal. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's clipping the first pulse. So it kind of eats the first samples when converting to analog.
We've seen this before. So what I end up having to do is I start the recording, I leave a lot of buffer, and then I restart the recording. And then when I'm done with this file, I'll just chop off the beginning of that. And that's how I've gotten around this before. But I've run into this quite a few times. I think it's because it could be that almost like a noise filter, so that it doesn't output any audio until it hears input come through. Just a guess.
Something you don't want. That already tells you this you probably don't want. It's gonna eat some part, and we can measure. I'm showing on screen one of the pulses, and I'm gonna measure how long the pulse is. I know how long the pulse is, but I'm measuring it on screen so you can see it by yourself. It's 0.33 microseconds or let me go it in samples, which is easier. It's 588 samples long, each pulse, okay, at 44 kilohertz. And I'm going to set this and set this. And there you go. It's eating 200 samples. And well, that's exactly what's happening. I could, from this data, extrapolate it and tell MD Fourier to compare them where it's supposed to start, but we'll wait for Bob's test and see if that's better. Okay, for us.
Yeah, it's all done here. So
yeah, that was faster than me doing it manually.
Save. By the way, I have my RescueZilla USB stick that I've been using to transfer the files back and forth, and I've made this months ago, and I still haven't had a chance to test RescueZilla.
Happens a lot. Mm-hmm. Yeah, the sync is there, but it was wrong. And here's the second test. We'll see if the sync is fine. I'm really bad at that, but I'd love to have a graphical interface that shows in MD Fourier the sync pulses, but no, I'm not going into that hole.
I mean, I think as long as we could just educate as many people as possible on how to use it and why we're using it, I think people could get used to just seeing these things.
It's simply bad again.
It's bad again.
Yeah, I could align it. Let me show you on screen. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11. They're 11. Yeah. Yeah, they were 11 pulses in this version. I don't remember that. Let me check the original, just to the digital one, just to make sure I'm not recalling things wrong. They're probably more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, they are 13 pulses. And it ate not just one pulse, it's eating 3 or 4 pulses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's eating 2 pulses now.
Okay, well, I've switched over to doing the Schiit Modi, and so we could make sure that it's the JTech that's actually bad and not any of the test things that I'm doing.
No, I'm sure it would be impossible to be something else because if you see my screen, the audio it's there. It's just simply when there's sound when there's silence, it's clipping two pulses that should be here.
Jeez.
It's eating them up. So it's just as you said, it has like a gate, and it won't go through the gate unless there's been enough sound in the buffer for some time or something like that. Extreme says, yeah, I've seen this before. You need to add a -1 divided by 32, 7, and 68 bias. Hey, Extremes, it's great to see you around here. He's been doing some awesome tests with MD Fourier regarding the GameCube. I don't know if you've seen them, but if you haven't, you should. You simply should, because he's been making measurements between cables and all these digital output interfaces that the GameCube and the Wii have. And he's been creating a wiki with this information. And it's really, really, really a very important resource for anybody interested in GameCube audio. Why that constant? Because reasons. Okay, I could manually align them, but and we'll get awful results.
Yeah, I think we should just move on because I think that thing's a giant piece of crap for analog.
No, that's for sure. It's eating up samples. That's.
But Just to
That's a
be clear
fact.
though, when I referred to that as a giant piece of crap for analog, I have a feeling that a lot of these devices, so like this device that we were just testing, so it's got 4 digital inputs, 2 of each style, and then 1 digital output. I think in many cases, the analog output of these is really just used for people that are like, all right, hey, plug in some headphones and make sure I get some audio type of thing. I don't think these are truly designed as, oh, listen to this awesome quality DAC. I think this is,
Yeah.
hey, you could have 4 sources to 1 output, and oh, by the way, we could stick a cheap, crappy DAC in there.
Yeah, it's like a service, right? You get this. This is a bonus. It's not the main use. Is this to provide a standardized stack for use with ME4? No, not at all. It's for testing this equipment and either recommending them or not. Hey Bernard, check this out. What we got from this DAC, and the MD4 audio file has 13 pulses, and it eats up 2 pulses at the start, 3 if you let it, if you don't buffer the signal. So here we only have 11 pulses from the 13 that went sent. Imagine that. And it's probably eating some part here. You can see clearly at the start of the signal, it's eating the start of the wave. So it's destroying the signal in the process. And every time the signal goes to silence, it'll probably, here it is, it's eating the start of the signal. On every single segment, it destroys the start of the signal. So yeah, don't use this for audiophile purposes. It'll be good for casual listening, and yay, it makes sound. Just check this fade, and this will make Bernard happy to see how this fade is managed by that DAC.
Hey, what's up,
But
Bernie?
yeah,
So this is the JTech Digital. It's really a 4-in, 1-out optical audio switch. So it has 2 of the Toslink, 2 of the coax, and 1 digital out, and then also has analog out. And I was using this up to my TV for a little while, and I was using it through a very nice amp. And the moment I switched over to the Schiit Modi, even my wife was like, "There's absolutely no comparison. You don't need to run a test. You don't need to do anything. This is so much better." So yeah.
the shit now. There it goes. Minus 93 decibels. It synced immediately. It's a slightly jittery, but not bad. We're talking 1, 2, 3, 4, 5 decimals of a frame of jitters, which is very small. And let me show you the results in screen right now. Adding them to the stream. There it is. There you go. This is the result.
That's
you're
very good.
seeing them. Yeah, that's very good. And
So just because this is by far the most expensive thing we're testing today, is there any other thing that you could show, even if you drop it in the chat and I could make it full screen? Is there anything else that you could show that would demonstrate why this would be $180 and some of the other ones we're going to be testing would be, 20? Because with my ears, I could certainly tell you, but it would be very cool to have a graph or something just to show people.
this is analog or digital, the shit deck?
This is digital to analog, so that's the analog output of it.
Okay, this is analog. It's really good. I mean, we have the small jitter, and we have a crackle noise that is between the test that the DAC made or the output or something. Let me show it here. I'll send you the files. Okay, let me zip the whole folder and send it to you. You have WinZip or something?
Oh yeah.
Okay.
Fair question though, because if I was streaming off of the Windows 7 PC, I would not have. But now I'm streaming from my main PC.
Yeah. That's why you asked, and it's always best to be certain. Here's the zip thing. Here's the whole result from this card.
Okay.
Okay, and this was analog. And checking the chat. There you go. You got it? Yeah.
Yep.
And this is. I mean, it's good. It's not as good, obviously, as the audio card. It's good. It has some slight noise, but nothing bad. Let me show you the graph in detail so I can talk you through it. Okay, I have it here. Slightly. Let me zoom it in a bit.
Yep, and I'm adding it here as well.
Okay, so if you have it, I'd rather talk about what you have on screen.
So I'm gonna put the first one up.
Yeah, that's good.
Okay.
You can see that first of all, your attention should go down to the right, and you have a 75 hertz signal as a reference and a 74.999994 hertz signal as your comparison. That tells you that there's a very slight amount of jitter, but it's not big. We're talking 5 decimals from a hertz, okay? And so that's 10 to the minus 5 error. On the top right, you have 93 decibels of noise. You have noise floor at 93 decibels. That means that MD4 found the first noisy stuff in the part of the silent signal down there. We can watch that graph later on. Around the 0 dB line that you have in the middle, which is an empty graph would be perfect, which is what we saw with the digital to digital comparisons. Here we have a small halo around the 0 line. That's the amount of noise. This kind of noise is way lower than what you get from an MP3. Okay, an MP3 gives you a hazy blur around the 0 dB line, but it's a straight line. There's no frequency distortion around this. So you have a straight line telling you that every frequency is at the volume that it was reproduced in the original file, which is good. It has no coloration. It doesn't color it either towards high end or low end, anything. It's very flat. On the top, on the bottom left, you have the differences in some bars. Those bars tell you, the first on the left tells you if everything was matched. Okay, and yes, everything was matched up to a 99.99%. Okay, in general. Then the second set of bars tells you if there was any difference around 1 dB. So with a 1 dB tolerance, everything was within a 99.89%. Perfect. Okay, good. Perfect matches, there were 0. This would only make sense in digital. Okay. The next two blocks tells you if there are frequencies that were supposed to be there but are not there, and there is 0% of those, or almost nothing, a bit below the 0.2%, which is really good. And the extra is usually distortion or aliasing or anything like that, and there is no extra data either. So this is good.
That is very cool. Is there any other image that you would like me to put up?
Let me check them if there's something significant that we can talk about. Checking the sinks. Sinks are very good, so no need for you to go there. Checking the time spectrograms. They're really good, no problem. Checking the noise floor if that gives us. You can place the noise floor one that's called NFSPB, or I can drag it. I can drag it to the chat if that works better for you.
Right there. I had it all queued up. I think that's the one,
okay.
Right?
Yeah, that's the one. That tells you the noise floor of this DAC, and from left to right is the frequencies from the low end to the higher end. And the line that is drawn there that says significant is the highest noise that was found in the analysis frequencies, and you can see that they match to the highest bar in the white space, and that's what you get. You get a very flat noise floor with some noise around the 60 hertz, which is of course to be expected due to the electric group and everything. Uh, but you can see that the real noise in the audible frequencies that you were working with is below 120 or around 120. Okay, and that's your base or average noise floor. That's what you get. So those are the most relevant ones in this analysis, I guess.
Okay.
It's good. It's really good.
So what I'm testing next is, I don't even know if this is going to work, but I have an HDMI switch that I want to test the digital and analog output of it. So I'm going to try to use my NVIDIA graphics card as the playback, and then of course the M audio for the recording. So it looks like the highest this can go is 24-bit 48K. So that's cool. I'm going to set this one to 48K to match as well. Because we're doing external digital signals, I'm going to check that off this time. And I think the only other thing to double check on the hardware is the recording device. Ooh, don't fall. All right. Ah! Stay right there. So one thing about using really thick, short cables, because, you know, the shorter the cable, less the interference, it's a giant pain to keep everything together.
Yeah.
All right, set it.
Yeah, it's a really complicated setup.
Recording properties. Okay, so it's not giving me the setup because I have external. That's perfect. Device setting this. SPDIF. That says 44 though. It says 48. Let me close that. I think this is where we have to set it to external after it's playing back. I think this is the scenario. Okay. Yeah, okay, 48. The last time we did this live stream, I had to reinstall Windows. It was kind of a mess, whereas this one, I feel like so far this live stream is going to end up being a really good tool for people who want to use this to try to do their own testing. I made all the mistakes on the first one. Okay, so can I switch? I guess not. All right, we're going to have to try it this way then. I don't even know if this will work, so let's
test it.
I mean, so it's working. That's good, but is it going to stink or not? Fingers crossed, everybody, because if this works, then this is going to be a very easy way to test HDMI devices from now on. There aren't too many devices left to test there, Artemio. I appreciate your time very, very much.
No, it's great to be around. And thank you for showcasing the tools and showing people what it is.
Oh yeah, I love it.
Okay, I'm trying to patch manually your previous analog file, so we can have an estimated.
Yeah, I think I sent the 192 through the shit as well.
Okay. Yeah, I didn't see. Sorry, I was entertained with this. I'm almost done, so we can have the results from the previous DAC. Just to make believe ones, because I'm cheating to get it to pass the sync. Okay.
I'm excited to see
and
it. So
then
I'm
we'll
gonna just
move
keep
to
testing away
this.
with this while you're doing that.
Okay, got it.
Hey, have you or Don or good catch for me. These little devices, have you seen any that destroy the signal? These tiny little 3.5 millimeter breakout adapters? Because
Haven't
I
seen any,
haven't
but
really.
it's very obvious when they do.
Yeah. Okay. Well, I'll give this
They
a
have
try.
like failed completely. It's usually they introduce either noise for bad contacts, or they have like a short circuit or something. So it did pass with my manual patching. I tried to be as close to the original as possible, and we're gonna have the results from your how's it called? JTAG, digital to analog converter.
Oh, it's gonna
Okay.
be so bad.
Okay, they're kind of making move, but they did patch nicely from what I see. This is not it. Give me a second to remove this. Sorry, I didn't see the other, but I was busy, entertained, making this happen. There we go. There's your result from your previous DAC. So yeah, it's not good. You see a cloud there of results. I'm going to send it to you, so you have it. But here it is.
I am almost done with these two, so I'll send these over. This one looks terrible already.
Yeah. There you go. With the average lines, and I'm gonna send you the noise floor as well, and the time spectrogram, and that's it. There you go. So this is it. It shows that it has a very big variation, and we're talking, just to quantify it, 7 decibel spread, if you want to call it some way. It has a lot of aliasing or distortion. That's why extra also shows. We have a good noise floor. That's something good to say about it. But yeah, it's not good. This is the extra, and this is the stuff that wasn't supposed to be there. So you have crosstalk, and you have a lot of aliasing that's not supposed to be there. And this is the noise floor, which is not bad. And this is what it does to the signal. It has some spikes there, interesting spikes. I don't know. I'm watching the preview from OBS. Let me see. Locally, you have a huge spike between like around 500 kilohertz, about 500 hertz. Sorry, that shouldn't be there from the fade. So it had issues with that. It's probably distortion since it destroys the signal. It causes some how you said, harmonics to be there that didn't exist. So well, now we go on to the real tests that we wanted to do. Sorry, and downloading. I have the yeah. So the only other test that I have pending is the Schiit to 192 kilohertz, right?
Yes, and then I have two more coming at the moment. Wow, these are
But
bad. These are really bad. Oh man.
I can send you the full folder zipped if you want me to.
Yeah, if you
Just
have
let me know.
time, just because it would be easier to archive this. But yeah, that's pretty terrible.
Yeah.
Okay, DAC testing. So what we're about to test now is going to be interesting twofold. One, because I would like to test this HDMI switch, but also because this might very well determine if we could ever use this 1070 graphics card on this PC with this power supply, yada yada, in order to get HDMI loopback stuff done. If we can, then excellent. Then I'm probably never. I'm gonna leave. I'll probably rebuild Windows 7 on this, retest the loopbacks, and never sell this machine again, because then I know it's just an MD Fourier test machine.
Okay, sorry, I was just cleaning up. I'm testing 192 kilohertz on the Schiit that made very good results. So I'm running them right now. And yeah, of course, I didn't change the reference file. That's like, and I made a mistake in our previous. It should be even better, the Schiit DAC, than what we measured right before, because I compared it to what MD Fourier outputted. So, well, it's not a bad test. It's a good test because it's
Oh.
real. It checks the
Wow, so
transparency.
even with the wrong comparison file, the shit actually did grid? Did well?
Yeah.
That's
Yeah, but
fun.
I used the loopback test, which is not bad. It tells us it eliminates or reduces the noise from our test. So the results are valid. I'm gonna rerun them and send them to you clean, but
Okay.
they're good. Okay, 192 is really good. Let me show the displays on screen and send the file to you. And add it here to the folder display and sending it to you in a minute. But here it is. Okay, there you go. Zipping it and sending it to you. Okay, done. Sending it now. Here it is. There you go. And download the others. So it's really good. Okay, 192 kilohertz. It's really good. And now for your test. Downloading. Okay. And made a mistake. We go again.
I'm just gonna throw up
Re-downloading.
the file that you just sent me here, just for people to see who's interested.
Sure.
So
You want to see the digital first or the analog first?
digital, please, so that way we could tell if the video card will work. Yeah, this is cool.
Go. I have it here. And minimizing this, running MB Fourier on the new files, which is 48 kilohertz. Resetting to 48 kilohertz. Here we have the proper source for 48 kilohertz. And now your digital extractor. There you go, running.
Fingers crossed.
It found, okay, minus 116, which is default, so it's probably, it says reference signal is digitally generated file, no noise found, using minus 116 arbitrarily. So it didn't find any noise in your sample either. Obviously, because it's digital, but it's good to confirm. And there you go. Here's the result. Not as good.
Oh, the digital didn't do so well, huh?
No, it didn't do well. It has jitter. It runs fast. It runs at 74.99, and you have some aliasing. Yeah, a lot of aliasing. Let me show you the image that has that extra aliasing, and that's what's causing the issue. You can see it there.
Okay, I'm
And
gonna run
it's
one more test then with a device that's a dedicated HDMI audio extractor that should. Actually, no, I'm gonna take a device that we had already tested last time, and I'm gonna use that to extract HDMI audio, and that will tell us if the problem is the switch that I just tested or if the problem is the video card. So I will. Let me jump on that right now, real quick.
okay. I'm rerunning the test right now. And what I'm doing is using an option that's minus R that allows MD Fourier to resync everything and remove the errors caused by jitter, only by jitter. It's but the issue is still there. The problem is aliasing, and we have a constant and periodic error in this source.
Damn.
Yeah, I'm gonna show you both plots that do show it. But I sent you the zip with them. There you go.
All
I'm
right,
gonna show it on screen on mine, and this is the noise. Well, this is the distortion that we're getting. Um, It's always we personally use Windows. Would you like to listen on a microphone? No, but it's fun to hear all the tones. uh, mm,
That would
Bernard
stink
says,
if the video card won't do what we need. I could pull another HDMI device out. I think I still have the CD, and we could use the Oppo player.
yeah. We've seen very good HDMI devices perform like standalone Sony players, and they do really well by HDMI. And also PlayStation 3 and that kind of thing. We've done those tests, and they weren't bad using HDMI.
Well, unless my memory is serving me wrong, because we did between you, me, Bertie, and T, we have tested probably 40 of these devices. So I think the one that I'm using right now is the one that you own. That I tested mine as well, and it performed very well.
It's not the main one I use others, but I'm using it to transmit, so. But I have one of these, yeah.
Is it possible that I just should turn the volume down when running this test? If it's clipping?
Let me check if it's clipping. Give me a second.
Okay.
I'll check it with you guys on screen by opening Goldwave and check the clipping live. I just need to open Goldwave. There we go. It is there, and the file, it's a digital, okay? It might be clipping, might not. No, it's not clipping. It's up there, but it's not clipping. It's using the full range.
Don and Bernie got in my head.
Yeah, it's up there, but it's not clipping. You can see it here. Yeah, that's good. That would be exactly 0 again, and yes, it seems to be exactly 0 again. Let me just bring up the source so we can see how it's made from the source. And
Don,
the
you said we
source
got a mute audio. You can't hear anything. Am I too loud? We're not running these audio tests through the speakers, obviously.
So the source is the same. Okay, he means that they are listening to the MD Fourier tests. I don't know. Oh yeah, they did hear the audio tones playing back to them on the stream.
Wow. Okay.
That's what they meant.
That's crazy, and I apologize. I didn't realize I hadn't.
No, you shouldn't
I didn't
apologize.
have it set up. No, I didn't mute it. That was my fault.
No, the tones are lovely. What do they mean? I hear those every day.
I saw people making comments about this audio spike, and I thought they were talking about when I get close to the microphone. I didn't realize MD Fourier was playing through. I'm really sorry. That's terrible.
It isn't. It's angelical sound. Of course, in terms of angels piercing your ears.
Okay, I'm just dropping in the two. This is the splitter that you and I have tested before.
Okay.
So if this fails, I mean,
Something else.
yeah, if this fails, it's going to be the video card. And
Yeah. These two that you just sent me, right?
yes.
Got
Thanks
him.
for swinging by, Bernie. I guess he had to go.
Yeah, yeah. Take care. Love you, man. Okay. Copying the first one, and now copying the second one. So you recorded it at 70% volume just in case. Good. Better to cover all bases. And let me run it on. I'll run the 100% first, 48 kilohertz. Okay, got the proper settings, and I'm loading the splitter audio extract 48 kilohertz digital, removing this option and running it.
While you're doing that, I'm trying to find my CD that had it already burnt onto it that we were using to test Saturn. I don't know what I did with that.
Oh, Saturn, yeah. And we need to test Dreamcast, man. I've not had the time since I've been working so much on the suite, but we already have MD for Dreamcast and for the BMU. I bet people will love listening to the tones of the Dreamcast BMU being played live.
Okay, where would that have gone?
There you go, and you won't like this. This is the 100%. I'll run the 75% right after it.
Oh, that stinks. All right. Well, I found the CD, and I have the Oppo player ready. So this should only be a second to get this switched
Sure.
over.
I'm running the 75% now, just in case. If that works, well, you know it was volume, right? Running the 75% one. Okay, it did find some noise at minus 117. So let's open that up and check it out. And no, 75% is better, but it's not good.
Still a fail. All right, I'm grabbing the Oppo right now. That should be up in a second. We should be able to blow through the rest of these.
There you go. Here's the 75% one, results on screen. Okay, Deluca, thank you very much. I have to go as well. I just want to see those last two tests, and then I'll be off. So there you are. Oh, to pre-folder material. Yes, the legendary pre-folder. It's a folder I have with stuff that looks nice, and obviously it's usually stuff that's bad. Bad, not in general, bad in terms of the audio quality, because you only get pretty patterns when there's differences. So yeah, no, this didn't work.
Okay, let me.
We still get those problems with aliasing and stuff. Here they are. This is 75%. I'm going to show you to the audience. There they are. These are the problems. This is the missing stuff. So it kind of skips stuff, frequencies, and it adds stuff. It's probably jitter and delayed. It's very periodic, and it's added in chunks. And Lucas says, my money is on the video card, HDMI being at fault. HDMI audio spec is terrible and not made for precise measurements. And with that, I have to run. Thank you all so much for the stream. Been lots of fun. Take care, my friend.
Thanks,
And
Don.
take care, Don.
So we won't need these anymore for these. We'll only need the recording. (24-bit 44), okay. Device is 44. This one's 44, and all right.
I just made a zip with all the results, and I'm sending it to you.
Okay.
Okay. I bet it's a general issue with GPU HDMI out.
Yeah.
I bet consumer level is better in general.
All right. Okay, so what's going on now is we have the Oppo Digital UDP. What is this one? I keep forgetting this model. UDP 203 Blu-ray player that also is known for being pretty decent at other stuff, and we are using that to go HDMI out to this HDMI splitter with digital audio extraction that Artemio and I have tested before, just to verify that this is going to work, because the video card did not.
Yeah.
That. Digital. Oppo.
So yeah, if you're anal about your audio, don't use the HDMI out for audio. This is not necessarily something that you'll notice on regular casual listening.
Yeah,
But
thanks for bringing that up, because I usually remember to say that when I'm doing the weekly roundups, but in these streams, we get so into our tech talk that I very often forget to say that when we're saying things like, oh, you can't use your HDMI output of your video card, you can't use it for testing. It probably sounds great hooked up to speakers, you just can't use it for MD Fourier testing.
Yeah, and another thing, just be aware that it's not perfect. It has that data we show. It's real. It just has some variation in the same level, and this is important, than an MP3 would. And meanwhile, while you're setting it up, I could just do that and show what an MP3 does to one of these files, right? I'm going to convert one of these samples to an MP3, and I'm going to run it through MD Fourier and show you how that looks. Okay.
I sent you the audio file as well, just to make sure that that we could continue.
Yeah, sure.
Okay, I should get this.
Got this converted, and I got the file, downloaded, and ready to test. Done. It's 48 kilohertz, and we're gonna run that before the MP3 because we're all set up. It is, and Oppo, running the Oppo file. Okay, results are almost ready. It found no noise floor at all, so that's a good sign. Hope I didn't speak too soon. But and opening the folder so you can guys see it at the same time that I see it. There you go. There it is. And this is the result. It's not good.
Well,
It's
that
not
stinks.
good. Yeah. Wait. I'm using 48 kilohertz as a source.
Yeah, I had to go to 44 kilohertz for this because that's what it supports.
Yeah. So just completely disregard that result.
Okay.
And we've run the test. And good thing that it was catched. I'll probably add a warning when that happens. So
Oh, you know
because
what? I labeled the file wrong. That's why you probably used the other one. Oh, sorry about that.
yeah, don't worry. But I did catch it visually. It's still not good either way.
Oh, really?
Yeah. Yeah, we didn't get a good result. I'm showing it on the screen. I don't know why that would be, but we didn't get a good result. I'm gonna recheck that I didn't make any mistakes. But there you go. This is the result.
Oh, that stinks.
Yeah, something went bad. Checking the files and it's 44 kilohertz. And yeah, there's a slight
Should I have been using
chance.
the external sync source for this one? Could that have been it?
You did or you didn't?
I did not. Let me try it. Let me see if it'll even record. No. That all right. So
That's so weird that it doesn't let you change it to the external source. It means that it's not syncing. Okay. Checking the file myself and opening all the way and opening that recording.
I'm gonna send you one more. I just used the switch, and if this doesn't work, we're gonna I say we call it, and then I figure out what the problem is independently, and maybe we do another stream in a couple of weeks or something.
Yeah, sure.
That stinks because I know we got this right one other time.
Yeah.
All right, so.
Meanwhile, I'll show you just for fun.
Okay.
I'll show you the MP3 and what happened to the MP3. What happens to a file when you encode it as MP3? And at 44 kilohertz, I'm running that right now. And I'll show you the results in a minute while Bob gets that working. Oh, so you already got it.
Yep.
You're fast. Okay. Well, here's the results since I already had it ready. This is what an MP3 does. Okay. Here it is on screen. Send it to you, Bob, so you have it as well. This is the file encoded by lame as an MP3 and what an MP3 does to the audio file. So it's within range, and that's what I say. It cuts some frequencies and makes it like hazy. But let's go with what do we have to check right now. Downloading Bob's file. Got it. Got it in my actual tests folder. Done. Running the test, verifying everything. It's a 44 kilohertz output source. Source is right. Actual tests. And just checking it's HDMI. Checking the file name so I don't mess up. Got it. Running it. HDMI switch audio extractor digital 44 kilohertz OPPO .flac. It went lower for noise floor minus 174. And checking the files. That folder.
And as you're doing that, I'm taking the coax output of the Oppo, going directly into the audio M90 192, just out of curiosity, because we definitely tested that before.
Yeah, and this was not good either.
Mm.
That's the guy from the 240p test suite. Yeah, that's me, Josh. So yeah, this didn't work either.
All right. One last one to check, but I think we're gonna have to call it then. I don't know what happened. The Oppo
Neither
was
do I.
fine the
Neither
last
do I.
time we tested it.
It could be something. Does it let you change to external right now, or not?
Um,
You're naming already the file. So thoughts on a good USB AV interface for audio to digital conversion. Have my eyes set on a Model M4. The Model M4 is really good, but they did have to change some components in it during the pandemic. We have two revisions of it. The first revision is perfect, spot on. The second revision has some small filtering at 192 kilohertz, 24 bits, but it's really good anyway. It's not as good as perfect as the original revision, but it's good even though it did change. They did change some components. Everything detailed. If you want to go into the MD Fourier Discord, just contact me and we can arrange that, and you can read all the logs we have on that because it's a long discussion. So I'm running right now the version. Let me show you on screen what's going on. MD Fourier is running, and with what Bob just sent me. And we're almost there with the results. Hey, HG, how are you doing? Thank you. Dice, gracias por todo tu trabajo. Sorry for talking Spanish. He says, thank you for all your work. Thank you, HG, for being around. This room looks like a Sega 32X FMV game. He means the interface like Double Switch or any of those games, I guess.
That is kind of true. That is absolutely kind of true. That's funny.
Okay, so no, we didn't get it either. There you go.
So there's got to be something going on here, that because we definitely tested this Oppo before and it was fine. So I don't know if I changed a setting. I don't know what else we got, but I think we're gonna have to swing back to this one at a different time and try to. I'll try to figure out what went wrong, because I think every other device here is gonna have HDMI in, and I think what we. Yeah, I think that's gonna have to be.
Right.
We tested the other ones. We're gonna have to do HDMI with a Mac or something else.
You'll probably figure it out, and it'll be something very silly. And you'll be like taking a shower when it happens. Now, I can't correct it by software. That's not good. I was trying to use the feature in MD Fourier to correct for jitter, but the issue is not jitter.
Yeah.
It goes way beyond jitter.
Well, okay. Have you or any of the MD Fourier crew determined a video card that does have clean output, or is it going to be the same issue you ran into where there's just too many factors involved? Maybe this video card would be perfect in a different machine, but mixed with, this power supply, this wall plug, etc.
We haven't gone into that territory at all. It's unexplored territory. We haven't considered PC video cards as a source so far.
Okay. Well, looks like I have a project for myself. So this was pretty
Just
cool.
fine. I've never done that. I could test. I have a lowly 1050 Ti. I could test that.
Yeah, I mean, I think I'm gonna start testing the rest of my equipment here. The only one that I know for sure has worked was my MacBook. But I think we're what, 2 hours and 10 minutes in. I mean, what time is your dinner? Or is that coming up soon?
Well, that was 3 hours ago. No worries.
Oh, okay.
It didn't happen, but it was supposed to be 3 hours ago. Not that you should feel bad about it. I had breakfast late.
Sorry about that. All right. Well, I guess we'll do another stream testing HDMI DACs instead at a different time in the future. But thank you so much for your time doing this. This was absolutely awesome, and yeah, I'm looking forward to doing it again. Next time, I will spare people the first hour of double checking the audio card. I'll just do that myself and pass the results on to Artemio just to make sure before we start. And next time, we'll just jump directly into HDMI testing and get a couple of those done too. Because I think a lot of people have been asking about these things because, do you use an ARC adapter? Do you get this, either one of the digitals? Do you use any of the analog? How do you put this into an awesome 2-channel stereo? So we'll swing back to it.
Sure thing. Whenever, my friend. I'm really glad to help out, and it's always fun being around here. So just let me know, and we'll sort it out.
Thank you so much, my friend, and thank you everybody in the chat for joining. This was very cool, and we'll talk to y'all soon.
Take care. Thank you.